Components are everywhere. At the exterior scale, they connect us to vital utilities and provide paths and playscapes for physical activity. At the building scale, they work together to form a building's envelope and vital systems. And at the interior scale, they support and define our spaces with doors, partition walls, built-ins, and technology. A building envelope is the physical separation between the interior and the exterior environments of a building. A building envelope restricts the transfer of air, heat, water, light, noise, and contaminants. Click on each item to learn more. Click Next when you are finished. At the interior scale, there are additional criteria to consider when selecting doors, floors, walls, ceilings, and windows. In addition to the occupant's aesthetic choices and preferences, a designer must also consider a component's performance, how it acts to support occupant health, and the occupant's experience, how it aids and assists occupant health. Consider the example of a door. Is it visually attractive? But how does it perform? And how do users experience it? Does it limit sound transfer? Is the transition flush? Does it provide privacy? Is it accessible and easy to operate? Will it be easy to maintain in case repairs are needed? When selecting interior components, there are quite a few health-related considerations. Sounds are everywhere, but when they become disturbing or unwanted, they become noise. And 65% of employees report trouble completing tasks because they are distracted by too much noise at work. Noise pollution, both from outside sources and interior sources, detracts from overall health and well-being in a variety of ways, interrupting sleep, disrupting conversations, and diminishing concentration and productivity. Noise pollution is also directly linked to stress-related illnesses. It is helpful to have a general understanding of sound measurements, and metrics used to rate components for their sound-reducing qualities. Decibels, dB, a measurement of how loud a noise is. dB is similar to the volume knob on a receiver. dBA is an acoustic decibel modified using A weighting to adjust the frequency-dependent response of human hearing. Transmission loss, a measurement of the dB volume difference across a wall section. The performance of a wall will vary a great deal depending on the tone, frequency of the sound. Frequency, hertz, a measurement of the tone of the sound. Most humans are born with the ability to hear frequencies from about 20 Hz low up to 20,000 Hz high, but that range shrinks as we get older. Sound transmission class, STC, a method to measure sound reduction to compare various wall, ceiling, floor, door, and window assemblies. Higher STC is generally better, though not always. STC only considers frequencies down to 125 Hz. This can be misleading due to the fact that most sound isolation complaints are from noise sources that are below 125 Hz, such as traffic noise from airplanes and trucks, and sound from the average home theater. Noise reduction coefficient, an average rating of how much sound an acoustic product can absorb. Like a sponge absorbs water, an acoustic product absorbs sound, and the NRC tells us just how much sound those products can soak up. A designer has many opportunities to reduce both exterior noise and interior noise. Develop acoustic plans to locate noisy equipment in the space. Establish maximum noise criteria for mechanical equipment sound levels. Organize the program to cushion sound. Place more active rooms, such as kitchens or break rooms, in locations that buffer sound from rooms where noise is problematic, such as bedrooms or private offices. Use products and materials that support good acoustics, such as padding and floor underlayments, carpeting or rubber flooring, and sound-absorbing wall panels and ceiling tiles. Position interior components to limit reverberation and echo. Design and select components for sound absorption, walls and doors with a high STC, walls and ceilings with a high NRC, and solid, non-hollow core doors with gaskets or sweeps.